previous session we have discussed about regular expression for the following NFA. Here whenever we have DFA we have to convert the regular expression. So this is the given DFA, we have to convert the regular expression. We know that we have the Arden's theorem, R equals to Q plus RP. That means we have to convert the equation to QP star. Now the first step, we have to write all the incoming edges for all the states. Q1, whenever we have Q1, so we have the incoming edge, that is epsilon. It's very important. Q1, so for incoming edges from Q2, right? Q2 or input alphabet B, and from Q3 we have input alphabet A. So take this equation as 1. Next we will write for Q2. So Q2 incoming edges only from Q1, that is Q1A. Q3 incoming edge we have only from Q1, that is Q1 and input alphabet B. And Q4 we have the incoming edges from Q2, that is Q2A. From Q3 we have the one more incoming edge on input alphabet B, Q3B. And Q4 we have two edges like A and B, right? Q4A plus Q4B. So write the equation numbers. Now we have written all the equations for Q1, Q2, Q3, Q4 based on the incoming edges. Let's observe the DFA. Q1 is the final state. We have to take the regular expression for the Q1 itself. So here when you observe the equations, Q2 has common Q1 state, Q3 has again common Q1 state. So Q1 we have Q2 and Q3. So whereas in this equation I am writing Q1 equals to epsilon plus Q2 means Q1A epsilon plus Q2B plus Q3A. This is the equation number 1. Q2 means we have Q1A, so based on the equation 2, plus Q3 means we have Q1B based on the equation 3. So Q2 means Q1A, Q3 means again Q1B. Shall we take common of Q1? So take the Q1 common, we have AB plus BB. So whenever we have same state as the LHS side and the RHS side, we can take it as R. Take it as R, Q plus R into P. That means QP star. What is R? Q1. Q means epsilon. P means AB plus BB. QP star. Epsilon into whole star. That is AB plus BB whole star itself. This is the Q1. So we don't have any states in the Q1, right? So take it as the equation number 5. So when you observe the given DFA, Q1 is the final state, right? So for the final state we have reached the regular expression. So not to do anything for the equation 2, 3 and 4. We can stop for equation 1 itself because Q1 is the final state. I reached the regular expression for the final state, so that you can stop this process here. So the final regular expression is AB plus BB whole star. So whereas in the last problem, so we have taken the Q4 as the Q3 as the final state, we have reached all the Q1, Q2, Q3. Here as the initial state, Q1 as the final state, so we have done only for the Q1 itself. We have reached the regular expression for the Q1. So we have stopped the process. Like this we have to check so what is the initial state and what is the final state. So for the final state we have to get the regular expression and we have to stop the process. So otherwise you can see more example. So whenever we have multiple final state, what we have to do? So when you see this finite automata, so Q1 as the initial state and we have Q1, Q2 both are the final state. Whenever we have the multiple final state, what we have to do? The first step as it is, we have to write the incoming steps. So for Q1 we have epsilon and also one more incoming edge, that is Q1 0. Next for Q2, we have Q2 1 as the one incoming edge. For Q3, so we have two incoming edges like Q2 0 and Q3 1. Write the equation numbers. Yes. Now if we observe Q1, Q2 are the final state. So let's take the first equation. So we have Q1 and Q1. So take the first equation, Q1 equals to epsilon plus Q1 0. Here we have Q1, here we have Q1. At the LHS side and RHS side, whenever we have the same state, apply Arden's theorem. That is, this is R, this is Q, plus this is R, this is P. Whenever we have this format, we have to write it as R equals to QP star, right? That means what is R? R is Q1, Q epsilon. What is P? P means 0. Epsilon into 0 star. So 0 star itself. So we have reached the Q1. Not to stop, because Q1 is the final state, not to stop here. So we have to check. Here we have the multiple final states. That means we have to reach Q2 also. So what is the value of Q2? Q2 is Q2 1. Q2 is, Q1 1 plus Q2 1. Here we have one more incoming edge for Q1 1 also, right? So take the equation number 2, Q2 equals to Q1 1 plus Q1 1 plus Q2 1. Now observe here, we have Q2, Q2. That means, right, because of Arden's theorem, R equals to Q plus, now R is Q2 and P. That means QP star, right, R equals to Q1 1 into P means 1 star. So 1 into 1 star itself, or otherwise apply Q1. What is the value of Q1 is 0 star. So right, so Q2 equals to Q1 means 0 star, 1 into 1 star. So we have Q2 0 star, 1 into 1 star. So this is equation number 5. Now let's observe here, we have the Q1 and Q2 both are final state. We have to do Q1 union Q2 for the final regular expression. What is Q1? Q1 is 0 star plus 0 star 1 star. So 0 star plus 0 star 1 star. So what we will get? We will get it as 0 star 1 star according to our identity rules. This is the final regular expression. That means whenever we have the multiple final state, so we have to reach Q1 and Q2 and apply the union operation. So that means, so whenever we have the single final state, we will reach to that state and we will stop the process. Whenever we have the multiple final state, we have to reach both Q1 and Q2 and we have to apply the union operation. So that is the conversion of finite automata to the regular expression using Arden's theorem.